My name is Darren Tan. I'm a going to be fourth year PhD student, and I'm co-advised by Professor Shirley Meng and Professor Zhen Zhen at the Nano Engineering Department. And I'm working on all solid-state batteries and how we can make them better, cheaper, last longer, and also solve some of the safety problems we face with lithium-ion batteries today. I think material science offers the ability to bridge fundamental science towards actual real-life applications within a relatively short or achievable time frame. So the same scientist who discovered a particular technology will be able to see it reach the market or reach a consumer within his lifetime, maybe even within his own career. So as an engineer or scientist at heart, this is something that makes material science exciting to be in. I feel excited not so much by what I'm making, but what are the possibilities that it could open up. Because a lot of the times, the technology that we build today would enable products or capabilities in future that don't exist today. To give a simple example, back just 10 years ago, 10 years is a really short time. When I was in high school, electric vehicles were hardly on the road at that time, but now it is everywhere. So within a short period of time, some scientists, just 10, 20 years my senior, created some product that could allow ubiquitous deployment everywhere in the world. So I hope that what I'm working on today, along with all my colleagues and with my professors, will be able to do the same 10 years from now. Like in the 70s, we will never imagine putting batteries in a flying vehicle or electric car. But right now, it is conceivable. In future, it could be normal, let's say. Just discovering that technology in the lab, building that proof of concept there, allows us to open our imagination to say that, hey, in future, we could do all these possible things if this technology can come true. So likewise, for the research I'm working on, sometimes I like to dream or imagine what this could possibly enable in the future, and that's what gets us excited each day. We work in a pretty big group and a pretty big team, and this allows us to tap on each person's talents and each person's strengths, and we make up for their weaknesses and things like that. Not one student, not one researcher, not one PI can be good at every single thing, but we can be really, really good at a few things. And by taking multiple people's strengths and put together, we can create a solution that not one of us can realize. To combining elements of characterization, synthesis people, computation expert, theorists, putting them all together will become an inevitable part of the big picture research direction. Gone are the days where one student has to spend 5 years to do everything. Come and visit us, talk to the students, talk to the researchers, feel the passion or the energy that's there in the lab, and take a look at the lab, look at what we are building, and we can show it to you directly and demonstrate to you. And you'll see that it's real and it's really exciting, and we can solve some of your problems and some of the problems in the field. There are generations below me of equally excited and willing to learn students. And I'm trying to pass it on to them before I leave. And the next thing I need to know is also that any institution, not just IMDT, UCSC Spec Center, is not just a summation of the people there. It includes the alumni network also. It includes professors and students who are there and who were there before. And this network will eventually come back to it and contribute it as well. I'm excited about research, and I'm doing research now. When I leave, I'm not going to stop. I'm still going to keep doing it, and we're still going to have continued relationships with UCSD, and hopefully for the rest of our career. So we're definitely going to continue to interact with the industry, and we definitely, hopefully, even be part of the same industry or company in future. So I would say that this is not going to end.